All right, let's just jump right in. Today, we're going to break down a pretty wild coding sprint, how to take a bunch of source files and build a real, working AI-powered iOS app. And the craziest part, the goal was to get it to a production-ready state in just about 4 hours.
So this is the question that really kicked the whole thing off. It's not just about coding fast, it's about what's even possible now that we have these modern frameworks and on-device AI. This is the story of an app called VoiceTasks, and how it went from just an idea to a real thing in less time than it takes to binge-watch a season of your favorite show.
Look, you just don't pull off a sprint like this without a solid plan. This was the roadmap, an 8-phase attack that took the project from the absolute basics all the way through to the fancy integrations, making it accessible and even testing. We're going to walk through this exact plan to see how it all came together. And here's that number again, just so it sinks in. Roughly 4 hours. That's for the whole shebang, all 8 phases we just saw. It's kind of insane, and it really shows you what you can do with a clear strategy and the right tools. So, let's start at the very beginning. Before you can get to the flashy AI stuff or a slick design, you gotta do the foundational work. Every great app has to start with a clean, organized, and totally solid structure.
The first half hour was all about this, the essential grunt work. It started with just a default Xcode project. The developer had to basically rip out all the template files, create a logical folder structure for things like core services and features, and then bring in the 13 existing Swift files that had the app's main logic. It's not glamorous, I know, but it is the bedrock for everything else.
Okay, with that foundation in place, the focus could shift to the user experience. And this wasn't just about making the app look pretty, it was about designing it for a very specific purpose, and honestly, for a particular kind of user.
Now this is where it gets really interesting, I think. The design was explicitly made to be ADHD friendly. So what does that mean? Well, it meant animations had to be super fast and to the point. We're talking between 150 and 350 milliseconds, with absolutely no bouncy, distracting spring effects. The whole thing was built around voice-first input to make it as easy as possible to use, with a super clear visual layout so you're never overwhelmed.
And this is a perfect example of how that philosophy was put into practice. It wasn't just visual. Custom haptics and sound services were built to give you immediate physical feedback for everything you do. That little subtle vibration or sound confirms your action is done, and it creates this really satisfying, grounding experience for the user.
All right, now for the main event. We've got a solid structure, we've got a thoughtful design. Now it was time to plug in the app's centerpiece, its on-device artificial intelligence brain.
The tech that makes this all possible is Apple's Foundation Models framework. And the most important detail here is that everything happens on the device itself. It's an AI that can understand what you're saying without your data ever leaving your phone. For privacy, that is a huge, huge deal. And here's what that AI actually does. A user can just say something messy and human, like urgent meeting with client tomorrow, and the AI instantly figures it out and structures it. It pulls out the title, sees the word urgent and sets a high priority, and correctly parses out the due date. I mean, this is the magic, right? Turning a messy thought into clean, actionable data. But, working with brand new technology is never that simple. There were 3 little gotchas. First, there wasn't an easy way to check if a device even supported the AI, which meant a workaround was needed. Second, the AI's response was kind of hidden inside another layer of data, so you had to know where to look. And third, the AI model loaded up separately from the main app, so that had to be handled carefully to avoid crashes. These are the little battles you have to fight when you're on the cutting edge. So an app doesn't just exist in a vacuum, right? To be truly great, it has to play nice with the rest of the ecosystem, and, most importantly, it has to be usable by everyone. While trying to get it to sync with Apple reminders, a really tricky problem popped up. A data query that looked totally correct just kept failing with these vague, unhelpful error messages. So what was the solution? A classic developer trade-off. Instead of fighting the system, the dev just went with a simpler path. Grab all the tasks at once and just filter them inside the app. Sometimes the less elegant solution is the one that actually works. Now, what's really impressive here is that accessibility wasn't some afterthought. It was baked in right from the start. Proper voiceover labels for screen readers, support for the reduced motion setting, and it even includes a custom dyslexia-friendly font and high contrast modes. This is exactly how you build an app that works for all users.
Okay, now for the final phase of the sprint. This is where the rubber meets the road. You're testing, polishing, and dealing with all the strange, unexpected problems that always seem to pop up right at the finish line. And this just brilliantly captures the chaos that can happen during testing. When trying to run automated tests, Xcode's build system just decided to start spawning multiple copies or clones of the simulator, which all then promptly crashed. It's a hilarious but super frustrating reminder that sometimes our own tools can have a mind of their own. This chart gives us a really honest look at where the testing landed. The core logic is solid. 12 out of 12 unit tests passed, which is great. But because of those simulator issues and the fact that you really need a physical device, the UI and AI tests got skipped for now. This is what developers call technical debt, stuff you know you need to come back and fix later.
And if we look at the code itself, we see a pretty balanced picture. Some really strong patterns were used, like having graceful fallbacks for when the AI isn't available, but there are also clear areas that need work. The error handling needs to be more user-friendly, so people actually know what's going on if something breaks, and the logging could be better to help track down future bugs. No project is perfect, especially one you build in 4 hours.
So, after all that, what are the big takeaways from this whole sprint? Well, first, that 8-phase plan was absolutely critical. Second, building the project over and over again caught errors early. Third, having a non-AI fallback was essential. And finally, and this is a huge one for every developer out there, accessibility is a fundamental requirement, not some optional extra.
And that leaves us with this final thought. We just watched a developer go from a folder of files to a feature-rich, AI-powered, and accessible app in a single afternoon. If this is what one person can do today, what does that mean for the speed, the scale, and the very nature of how we build software tomorrow? It really seems like the future is getting here a lot faster than we thought.